Hi, let's talk about pressure and how pressure increases with depth. Pressure is force per unit area. So you take some amount of force and then you divide by some area over which it is acting, and that is pressure. We're giving it the letter P, so P for pressure, and the unit is going to be force over area, so you could say newtons per square meter. But that's special enough, pressure is special enough, we'll also call it the Pascal. So abbreviation PA, or that's a Pascal. The Pascal is a fairly small unit of pressure. We don't, for a human being, that's really not a lot of pressure. So when we work with pressure numbers, you can expect some fairly big numbers there. Atmospheric pressure is what, 10 to the 5 pascals, something like that. So it's a pretty small amount of pressure, because a newton is not that much force, and then a square meter is quite a lot of area. So Pascal, not very substantial. So let's set up some fluid. Like, let's think of water. It's always easier to think of water. And then you don't need a container, but it's easier to think of it as if you had a container. So let's put a cylinder and let's just fill it with water. So this is a beaker full of water all the way to the top. So the water surface is there. So that I'll just put surface. And we're going to count a coordinate, and I guess we'll call it H to agree with the book, but this H by convention is going to be going down. So we'll put H equals 0 there at the surface. And what's going to be at the surface, you're going to feel what we call atmospheric pressure. The pressure from all the air. And then as you go down, you go down deeper in this container of water until you're at the bottom. And so you could think that, okay, yeah, well, now I've got the pressure of the air plus all the weight of all that water on top of me. So that's going to add some pressure. So down up there, the pressure was atmospheric pressure. Down here, the pressure is atmospheric pressure plus something else, some more pressure. How much more? Well, it turns out you just take the H and the rho and G. So that's the extra bit there. So explicitly, the change in pressure from top to bottom of this container, so H goes this way, it's H to the bottom of the container. And so the change in pressure is H rho G. And you can hear my dog, because Governor Inslee chased us home, so he's seen a cat or something out there. All right, so this is the introduction to pressure. This is an equation to box up. So as you decrease, as you go deeper into a vat of fluid, this is the amount of pressure that will increase. You need the distance, you need the density of water or the other fluid you might be in, and you need the ever persistent acceleration due to gravity right there. So this is a super useful thing.